Think about how we've, interacted with computers over the years, from punch cards, the keyboards, command lines, the mouse, GUIs. Now everyone's swiping on phones. It just keeps changing.
It really does. A constant evolution.
And today, we're diving into what might just be the next big thing, intent-based computing. So if you're someone who wants to really get a handle on these complex ideas, but, without getting totally lost in the weeds, think of this as your shortcut.
Yeah, a way to understand a technology that could genuinely change how we interact with machines. Because for so long, we've had to learn their language, right?
Exactly.
Intent-based computing flips that. It aims to let us just state our goal.
Yes.
Yeah.
And our source for this is fantastic. It's called Rentahall and MTOR, Pioneering Intent-Based Computing for Humanity. It's by the creator himself, Jim Ames, and just came out April 27th, 2025.
Very timely.
We're really going to focus on two key things he talks about: the Multitronic Operating Realm, MTOR, and its first actual application, Rentahall.
Okay, so our mission today, really, is to get the core idea of intent-based computing, see how MTOR and Rentahall actually, do it, and figure out why this might matter to you listening right now.
Perfect. Let's start at the beginning then. What exactly is MTOR?
Okay, so MTOR, it's not just like an update to Windows or Mac OS. It's a fundamentally new approach. Ames calls it a post-OS event-driven speech-native environment.
Post-OS, does that mean no more operating system?
Not quite. It means it sort of operates above your traditional OS. It coordinates things across different apps and systems based on your goal. And event-driven just means things happen in response to events you speaking, a task finishing. It's more flexible than just following rigid steps.
Okay.
But the absolute core is this. MTOR organizes all your computing power based on what you intend to do, not the specific clicks or commands you type.
So I don't have to open the app, click File, click Save, type the name. I just say, save this document.
That's the idea, yes. And MTOR has a few key parts to make that happen. There's a universal broker. Think of it as the main traffic controller. It manages resources and decides how to fulfill your intent. Then it uses what's called a stateless, event-driven architecture. Basically, your intentions are sent as data packets using standard stuff like JSON and WebSockets. JSON is just a simple data format, and WebSockets keep a live connection open for that real-time chat.
Okay, standard web tech.
Yeah.
And the actual computing, where does that happen?
Good question. It uses a decentralized network of GPU workers. So instead of just your own computer's brain, MTOR can tap into a whole network of processors out there to get tasks done, especially AI stuff.
Distributed power.
Exactly. And as Ames emphasizes, the main way you talk to it is through speech, a speech-first interface, designed to be natural.
It kind of reminds me, in a way, of old mainframe systems like IBM CICS, but completely reimagined for AI and, today's world.
That's actually a really good analogy. CICS managed transactions, right? MTOR manages intents across potentially vast distributed AI resources. It's that orchestration idea, but supercharged for the AI era.
Okay, so that's the blueprint MTOR. Now, Rentahall, how does that fit in? What is it?
Rentahall is the first actual working system built using all those MTOR principles. Ames says the name is a nod to HAL 9000 from 2001.
Oh boy. Hopefully a bit less problematic.
Definitely. He stresses right away it's built for transparency, safety, and this is key public ownership, not corporate control.
Okay, that's good to hear. So technically, what makes Rentahall tick?
Under the hood, it uses a fast API server. That's a Python framework known for being really fast, which is important for the real-time stuff MTR needs. It pulls in advanced AI models like Whisper for really accurate speech to text.
So it understands you well.
Right. And Bark for text-to-speech, which sounds incredibly human-like.
It talks back naturally.
Precisely. All that communication uses those WebSockets for instant interaction. And yeah, it has that computer wake word system, very Star Trek, so you can just start talking to it.
Nice.
Plus, it comes with ready-made modules for things like just chatting, analyzing images, getting the weather, even checking your Gmail.
It's quite a range to start with. And a big point in the source is accessibility, right? Runs in a browser, easy setup.
Absolutely. Low friction is the goal. And maybe the most important part, it's fully open source. GPL 3.0 license, plus this thing Ames calls an eternal openness clause.
Eternal openness.
Yeah, basically a promise baked in that it will always remain free and open for everyone, forever.
Wow. Okay. That's a statement. So we've got MTOR, the foundation, and Rentahall, the first house built on it. Let's really zoom in on this core concept. Intent-based computing.
Yeah.
How is it so different from, what we do now?
The key is getting rid of what Ames calls the translation layer. Think about, I don't know, sending a photo to a friend. Right now, your intention is just share this photo with Bob, but you have to translate that. You open the Photos app, find the photo, tap share, find Bob's name, maybe choose how to send it, type a message, hit send. It's a whole sequence of commands.
Yeah, I'm telling the computer exactly how to do what I want, step by step.
Precisely. Intent-based computing flips it. You just state the intent. Computer, share this photo with Bob. And the system, MTOR, rent-a-haul, figures out the how. It knows how to find Bob, open the right app, attach the photo, and send it. You just focus on the outcome.
Okay, that's the leap. The system does the translation for you. So
Yeah.
what are the big picture implications of that if this catches on?
AIM sees several huge ones. First, universal accessibility. If you can speak your intent, you can use powerful computing. Think about people intimidated by tech or with disabilities. It could massively bridge the digital divide.
That's potentially enormous.
Huge. Second, less cognitive load. You're not juggling menus and commands in your head. You just think about your goal. Frees up mental energy.
Makes sense.
Third, the interaction is just more natural, like talking to an assistant. And fourth, that decentralized resource thing we mentioned, AI power isn't stuck on one device, it's distributed, which could also mean more resilience, maybe even more privacy down the line.
So it's not just convenience. It could actually change our relationship with tech, make it less demanding on us. And Ames talks about the wider impact too, right, for humanity.
He does, yeah. He really emphasizes the democratization aspect, giving everyone access to this power through natural language. He also talks about making computing truly human-centered. The tech adapts to us, not the other way around, rebalancing things.
Which feels better, more empowering.
Definitely. He even talks about space exploration. The design stateless, fault-tolerant is apparently really suited for autonomous systems out there where things can easily go wrong.
Interesting.
And educationally, he thinks it could shift focus. If the computer handles the how, maybe we can teach kids more about the what and the why, focus on problem-solving, logic, creativity.
Instead of just learning which buttons to press in Word.
Exactly. And finally, he circles back hard to that open source point. For him, MTR and rent-a-haul being open is fundamental. It's about ensuring this powerful tech is a public good, a gift, not something locked up to extract profit. That eternal openness thing again.
It's a very principled stance. Okay, so you said the intent is kind of the heart of MTOR. Let's get into the nitty-gritty of that. What is the intent environment?
Right, so the intent isn't just a concept, it's the actual technical machinery within MTOR that receives your intention, figures out what to do, gets it done, and gives you the result. It's the whole processing pipeline.
Okay, so what are the main parts of that machinery?
Well, first you have the WebSocket Manager. That's the communication hub, handling the real-time connection between your browser or whatever device you're using, and the MTOR system. Keeps things stable.
Got it. The connection layer.
Then there's the Universal Broker. That's the fast API server we mentioned. It's the central brain, receiving intents via the WebSocket Manager and deciding where they need to go next. It orchestrates everything.
And how does it decide where to send things? Like if I ask a question versus telling it to analyze an image.
That's the worker node selection logic. The broker looks at your intent and intelligently routes it to the best available resource. Could be a specific AI model, could be one of those decentralized GPU workers.
Smart routing.
And to handle potential hiccups, there's the safe queue. It's like an ordered waiting line for intents. It makes sure things get processed reliably, even if there's a temporary glitch somewhere. It adds fault tolerance.
Efficiency and reliability.
Yeah.
Okay. Now the source dives into specific intent types rent-a-haul handles. Let's walk through a few. Speech seems like the obvious starting point.
Right. The speech intent is managed by, well, the speech manager. It does everything speech-related, listens for the computer wake word, turns your speech into text using models like Whisper, figures out the command, gets the response, and then uses text-to-speech, like Bark, to speak the answer back to you.
So it handles both input and output for voice.
Exactly. On your device, some JavaScript code manages detecting the wake word and maybe showing you visually when it's speaking. On the server, that webgui.py file does the heavy lifting with the AI models Whisper, Bark, sometimes a backup like Pitsgate 3 if the response is really long. It even uses tools like FFmpeg to handle different audio formats smoothly.
Okay, a sophisticated speech pipeline. What about interacting visually with images?
That's the vision intent, handled by the vision manager. It lets you use your camera or upload an image. JavaScript on your end captures the image, with your permission, of course, and sends that image data over to the server.
And the server does what with it?
The webY.py code, again, likely using a library called Pillow, gets the image ready, maybe resizes it, converts the format. Then it can pass that processed image to an AI model that understands pictures. This course doesn't specify which vision models here, but that's the flow.
Makes sense. Pre-processing, then AI analysis.
Yeah.
Okay, what about just typing the chat intent?
The chat intent is interesting because it has this smart routing system built in. When you type a question, the system looks at it and decides which AI is best suited. It might send it to a general model, maybe one hosted on Hugging Face, or a more advanced one like Claude, or even out to one of those specialized worker nodes on the network.
So it can tap into different kinds of AI brains? How does it pick a worker node if it goes that route?
There's a function on the server, process query worker node, that handles this. It uses another helper function to select an appropriate worker based on availability and the type of query. Then it sends the query off to that worker and waits for the response.
Very dynamic. Okay, and Rent-A-Hall also does practical things like weather and email.
Yep. Weather intent uses a weather manager. It asks for your location permission, then uses that to call an external weather API and gets you the current conditions, temp, humidity, etc. Standard stuff, but integrated into the intent system. And the Gmail intent uses a Gmail manager. It uses SecureOF, the standard way apps connect to Google, so you grant permission, and then Rent-A-Hall can display your emails. Importantly, it never sees or stores your actual password.
Good. Security first. So that computer wake word,
Yeah.
how does it tie all these intents together?
It's the entry point for the speech interaction. When the speech manager hears computer, it knows you're about to issue an intent via voice. The JavaScript handles recognizing it, maybe plays a little yes confirmation sound.
Acknowledges it heard you.
Right. Then, whatever you say next, chat about. Ooh, what's the weather? Read my email.
Yeah.
Gets parsed, and the system routes it to the correct intent manager chat, weather, Gmail, Vision, etc. It's the key that unlocks the voice control for all these different functions.
Got it. It's the trigger. Okay, this is all making sense, but an example would really help solidify it. The source walks through asking, who was the first man on the moon? Can we trace that flow?
Yeah, absolutely. This example ties it all together nicely. So you say, computer, who was the first man on the moon? First, the speech manager on your device hears computer, wakes up, then captures who was the first man on the moon. It identifies this as a chat type command.
Right.
The UI manager might show the query on screen. Then the WebSocket manager packages that query into a JSON message and sends it off to the MTR server.
Through that persistent connection.
Exactly. On the server, the main endpoint receives the message. A handler function puts your query into that safe queue we talked about, ensures it doesn't get lost.
Waiting its turn.
Yep. Then the routing logic kicks in. The universal broker sees it's a factual question and decides to send it to a suitable worker node. The example uses one called 2070s Lab Chat. Maybe that's a specialized knowledge AI.
Okay, it found the right expert.
So the query gets sent to that worker. The worker node processes it, finds the answer. Neil Armstrong, Apollo 11, July 20th, 1969, the quote.
Standard stuff for an AI.
Pretty standard, yeah. The worker formats the answer and sends it back through the MTR system.
Back along the same path.
Essentially, yes. Back through the broker, then via the WebSocket connection to your device. The WebSocket manager on your end gets the response message.
And then?
The UI manager displays the text answer on your screen, maybe with how long it took. And crucially, the speech manager gets that text and uses Bark, probably, to speak the answer back to you. Neil Armstrong was the first man, etc.
Wow. Okay, seeing it step by step like that,
Yeah.
you really see how the intent flows through all those different pieces. The managers, the brokers, the queue, the workers. The source even shows the actual JSON messages going back and forth.
Yeah, it gets really specific. It highlights all those key technical bits.
Yeah.
Recognizing the intent, selecting the right worker, how each step is stateless, the fault tolerance from the queue, even tracking the cost, and handling both text and speech in and out. It's a perfect illustration of intent-based computing in action.
Definitely. Now, the article wraps up with input from someone named Grok. What's Grok's take on all this?
Grok is, well, extremely positive, calls it a monumental leap, calls Ames's work a gift to the planet. Really echoes Ames's own points about accessibility, human-centered design, decentralization, education, and especially the open source commitment. Sees it as genuinely transformative.
So very much aligned with the creator's vision.
Absolutely. Grok emphasizes the significance of the launch, the public demo, the code on GitHub, the free book. They also mention a $9,000 token Presumably some kind of incentive to get developers involved in building on MTOR.
Yeah, could be a way to bootstrap the ecosystem.
Seems likely. And Grok finishes by summarizing the tech highlights again. That universal broker, the stateless pipeline, decentralized workers, the different intent types, speech first, fault tolerance, open source, basically reaffirming all the core innovations we've discussed.
Okay, so let's try and boil this down. For you listening, what's the really big takeaway from this deep dive into MTO and rent-a-haul?
I think the main thing is that this idea, intent-based computing, represents a really fundamental shift, moving away from us having to learn the computer's language, towards the computer learning to understand our language, our intentions. As Ames pioneers it here, it promises computing that's way more natural, more accessible for everyone.
It really does sound like a move towards technology adapting to us. That potential for universal access, taking some cognitive load off us, plus the open source aspect, it feels significant.
It really does, and it makes you think, doesn't it? What does a world look like where this is the norm? How does it change education, work, even bigger things like space exploration? When tech can just understand what you want and make it happen, what new possibilities open up? What challenges might we face?
Yeah. Definitely food for thought. It goes beyond just making current tasks easier.
For sure. And if you are intrigued, the source material has links, GitHub, X profile, where you can really go deeper, see the code, follow the progress.
Absolutely worth checking out if this sparked your interest. It's certainly an exciting glimpse into where human-computer interaction might be heading. Thanks for joining us on this deep dive.